Okay, this is LeetCode 46, and so the key idea to solving this question is to use a backtracking algorithm. So above this, I've drawn a tree which has all of the decisions you have to make in order to create a permutation. So at the start, you start with an empty array, then you have to either start with 1, 2, or 3. If you start with 1, then you can either add 2 or 3 next, and then you fill in the remaining element. And so basically this bottom layer here is going to have all of the permutations which you want to gather and then return them as a list. So I guess in another way, this question is basically saying traverse this tree, get every leaf node, and then return it as a list. So the way to do this is with a backtracking algorithm, which is kind of similar to def or search for a tree, except you don't have this tree in the question. So basically how it works is you're going to go down all the way to the bottom. Once you have a number of paths, you're going to go up, backtrack up once. Since there's no other path here, there's no path like this, we're going to backtrack up again. Since there's a path, we're going to go down again, backtrack up, backtrack, go down, solve everything in 2, backtrack up, and then go down to 3 and solve everything in 3. So basically it's like a def or search, traversing a tree, except you don't have this tree and you have to figure it out. You have to create like the nodes yourself. So when you make a backtracking algorithm, there's like a general template you follow, which is like it's similar to a DFS where you're gonna like define a function. You're gonna have a base case here. Then you're gonna like loop through every option, every child node, which is basically every element that you can still pick. So I guess I'll say loop children. Terrible spelling. Let's use text. Loop children. You're going to call DFS on each of these children. So when you loop through 1, you're going to call DFS here. Then you're going to call DFS here, and then you're going to call DFS here. And then you return. So in that way, it's pretty similar to def or search. And then you're probably going to need a stack to store like this thing, where basically every time you add an element to your permutation, you're going to add it to a stack. So here the stack would be 1, and then here the stack would become 1, 2, and then here the stack is 1, 2, 3. And so basically every time you backtrack, you're just going to remove the top of the stack. So I backtrack up here, I remove 3, I backtrack up here, I remove the 2, and then I can, the loop goes through the next child, which is 3 here, so it's going to add 3. This explanation is not clear, I know, but sort of, I guess the way to do it is to do a backtracking algorithm. You just have to like look at a backtracking solution, see how it's done, and then sort of learn the general template for backtracking. Or you could search up like a general backtracking template and learn from that, and then modify it to solve this question. But yeah, that's basically it. You just have to make a backtracking solution, and then it's basically just take a template which looks very similar to DFS and implement it. So yeah, that's about it.